So welcome back everyone. This is going to be the second lecture of the MATLAB course, and in this lecture we will be learning how to create script files and how to write programs. But before we get started with the lecture, this should be the MATLAB window that is open in front of you. If it is not, go back to my previous lecture where I have shown you how to set up the software in your system. So let's get started with today's lecture. So to create a script file, you need to go to the Home tab and click on New Script, or you can go over here, click on New, and then click on Script, and the script file should open up. So the first thing that you should do is save your file. So go to Save, click on Save As, and save your file in the current folder. Recall that in our case, the current folder was MATLAB tutorial. So I will give the file a name. So let's say I name it tutorial_1. So while naming your files, follow the same conventions that you would follow while naming your variables. That is, no keywords, no blank spaces, and if you are connecting multiple words, connect them using underscores. You can see that the file extension is .m. So .m stands for MATLAB code files. So if you see any file whose extension is .m, you should understand that it is a MATLAB script file. So I will save my file over here, and you can see that the file name has been updated over here. And if I go back to my current folder, we'll see that the file name has been updated over here as well. Now, if you want to execute or access this file, all you need to do is double click on this file and the script file should open up. So there are several things over here and I will explain each one of them one by one. So the first thing that I want you to notice is the white space that you see in front of you. This is where you will be writing all your programs. But before we start writing our first program, I just want to tell the difference between writing a program in the script file versus writing a program in the command window. So I have already said this in my last lecture, but I will just repeat once more. So the command window is basically used for writing very simple programs, that is one or two lines of codes, and you execute those codes one by one and you get the output at the same time. However, if you want to write very lengthy programs, then usually the script file is used. The command window is not recommended in such cases. So in a script file, you can write all the lines of codes one by one and you can execute all of them at once just by pressing a single button. So let's get started with writing our first program. A good practice to writing programs is by clearing your variables and clearing your command window at the very beginning. So we already know the commands to do this. So we will write them down. So we write CLC and clear all. So here I have written the two commands in two separate lines, but you can write them in a single line as well. But for that, you need to separate each command by a semicolon. So what a semicolon does is it denotes the end of a line of code. It separates two lines of code from each other. It is also used to suppress outputs. So what this means, I will explain in a bit. But for now, we will continue writing our program. So in the last lecture, we learned how to create variables and how to perform simple operations like addition and subtraction. So we will do the same over here as well. So here I will create two variables, say a equals 6, b equals 7, and I will store the value of the addition of these two variables in a separate variable c. So I will write c equals a plus b. This is our first program and that's it, simple as that. Now if we want to run this program, we will click over here. And if I go back to the workspace, you will see that the variables a, b, and c has appeared with the value of c as 13. So the program has been executed properly, but nothing has been displayed in the command window. So what do you have to do if you want to display the output in the command window as well? So for that, you need to delete the semicolon from the line that is producing the output. So in this case, this is the line producing the output. And so if I delete the semicolon from the end of this line and run the program once more, you will see that the variable c has appeared in my command window with the value of 13. So as I said before, if you want to suppress outputs of a particular line, you need to use a semicolon after that line. If you want to display the output in the command window, don't use a semicolon. Now the next good practice of writing programs is to insert comments wherever you can. So a comment is a MATLAB text that is not executed by MATLAB, but it is only there to help the programmer or the user understand what the program is actually doing. Say for example, here I have written a equals 6. Now if someone else is looking at this program and he or she doesn't know very much about programming, so he or she won't be knowing what this line of code is actually doing. So if I insert a comment over here saying that I am going to now declare a variable a with a value of 6, that will be helpful for the user to understand what the line of code is actually doing. So this is actually a comment. So there are several ways you can insert comments. The easiest way is to start writing by inserting a single percentage sign and then writing whatever you want to write. So here I will write, say, declaring a variable a with a value of 6. So you can see that the color of this line is different from the rest of the code. So this is actually a comment and this won't be executed by MATLAB. You can convert any line of code to a comment by clicking on that particular line and going over here and clicking on comment. You can also comment a line by pressing Ctrl R on your keyboard simultaneously. If you want to uncomment a line, you can click over here, or you can press Ctrl T on your keyboard simultaneously, or you can delete the percentage sign as well. Now say I comment out this line. So what will happen? MATLAB will execute this line, that is it will clear the command window. It will execute this line, that is it will clear my workspace. It will create a variable A, it will create a variable B. But it won't be executing this line because it has been commented out. So if I run this program once more and go back to my command window, you will see that in my workspace, there is only the variable A and variable B. There is no variable C because it has been commented out. Good. So now we have seen what a single percentage sign does. It creates a comment. Now we will see what a double percentage sign does. So we'll go over here and we'll type a double percentage sign. Now as soon as I do that, you can see that a horizontal line appears, which divides this entire white screen into two parts. And these two parts are nothing but sections. So what a section does is it helps the program to be made more concise and compact, and it also helps in debugging the program. So debugging means finding and correcting errors. So if you have a large program and you have made several mistakes in that program, instead of running the entire program every time you correct a mistake, if you have sections in that program, then you can run each section one by one, and you can see whether that section contains any error or not. So making sections in your program actually makes it much faster to debug. So you can create sections by typing in two percentage signs followed by a space and typing in the title of the section. So for example, here I will write performing multiplication operation. And from the next line onwards, you can continue writing your program as it is. So for example, here I will write d equals 34, e equals 56, and I will perform a multiplication operation on these two variables. Now, if I want to run this program section by section, what I will do is I will click over here in the first section if I want to run the first section, and I will click on the run section button over here. So you can see that I have changed the variable of b to 76 so that you can understand that there is a difference between what we are doing previously and what we are doing now. So I will click on run section over here. And if I go back to the command window, you see that the value of C has been updated and the value of A, B, and C appear in the workspace. There are no variables D, E, and F in the workspace. This is because I haven't executed the second section as of now. Now, if I want to execute the second section as well, I will click anywhere over here and I will click on run section. And now if I go back to the command window, you can see that the variable F has appeared over here and the variables D, E, and F has appeared in the workspace. So this is how you create sections. So these are all the things that you need to know while writing programs in a script file. You can also write programs in another way, and that is by using live scripts. So a live script is the same as a normal script file, except that it offers a more interactive interface to the user. So you can create a live script by going to the home tab and clicking on new live script, or you can go to new and click on live script, and the live script file should open up. First step is to save the file. Click on save as. Save the file in the current folder, give it a name. Say I will call it tutorial underscore 2. You can see that the extension of the file is .mlx. MLX stands for MATLAB live code files or live script files. So save your file in the current folder. You can see that the file name will be updated over here. You can see a vertical line that is dividing the entire white screen. So on the left side of this vertical line, you will be writing a program, and on the right side of the vertical line, you will be getting the outputs to your program. So you don't have to go back to the command window every time you want to display an output. So this is how the live script offers a more interactive interface. You can write the program the same way as we were doing in the normal script file. So I will write the program over here, the same program. So I will write CLC clear all a equals 6, B equals 7, C equals A plus B. And you can see that as I am writing the program, MATLAB is offering me some suggestions of the codes that I can use. So this is also a benefit of using live script over the normal script file. So now if I want to run the program, I will click over here. You see that the program is running and the output of the program is displayed on the right side of the window. Now if you want to write comments, so what you have to do is go to a new line, click on text, and you see that the gray area has disappeared. Now if you write anything, that will be treated as a comment. So this is a comment, won't be executed. If you want to go back to writing codes, you have to click over here, click on code, and you see that the gray area has reappeared once again, and you can start writing your code from here. If you want to create sections, click on section break over here, and you can see that a horizontal line has appeared. You can perform multiplication operation in the next section. For example, d equals 34, e equals 56, f equals d times e. And if you want to run this section only, click on run section over here, and you can see that this section is running and the value of f has appeared over here. So these are all the things that you need to know while working in a script file. We learned how to create comments. We learned how to create sections. We learned how to save and execute our file. We learned how to create live scripts as well. In the next lecture, we will learn how to work with matrices and vectors and some very basic functions regarding them. In the next lecture onwards, I will also be working in the live script only because it is more interactive. However, if you don't have the option of using live script, you can use the normal script file as well. It will work just as fine as a live script. So let's keep this lecture till here only. If you liked this video, hit the like button and subscribe to my channel. See you in the next lecture.